looking like when you do that substitution. If this is much larger than this, what you get is 2 times K1, big K1, K2, O3 squared divided by O2. So the only rate constant, or the rate constants for equation 1 don't show up anymore. Only its equilibrium constant does. Again, that's just the definition of a quasi-equilibrated reaction, is that its transition state no longer matters, only its reactant product state. All right, it says that the reaction energy for step 1 is 50 kilojoules per mole. The activation energy for step 1 is 75. The activation energy for step 2 is 45. And it wants to know what is the apparent barrier under the conditions from part C. And under those conditions, the rate was again equal to 2 times big K1, little K2, concentration of O3 over O2. So what's the apparent rate constant? I mean, first, just K apparent, right, is 2 times K1 times little K2. No, because this is a big K1. Remember, under these conditions, so this becomes big K1, because you get little K1 over, it works the same way, though. I mean, you could have done this. You're going to get the same answer. Okay, so what is the apparent barrier, then, for this apparent rate constant? Does the 2 matter? Remember we did an example and we said the 2 was irrelevant? That it would only change things by like 1 or 2 kilojoules per mole, so you can neglect it? So what do we get from those 2 things? Which E, though? Which one E1? The reaction or the activation energy? No, it's a big K. So it's the reaction energy. And again, this works up here too. I'll do it up here. Plus the activation barrier for step 2. Because it's the rate constant for step 2. If you use the small k's, then it's fine to use the activation barrier. You get EA1 minus EA negative 1, because it's in the denominator, plus EA2. And now we're not given EA negative 1, so what is it? How do you get EA negative 1 for this reaction? Yeah.
It would be the difference of the reaction and the step
1. Trying to make sure the sign's correct there. So if you have, it goes up 20, but it goes down. So this is at negative 20, then the reverse is positive 40. Let's see if our numbers add up. 40 should be equal to positive. No, I think we have it backwards. Should be EA1 minus E reaction 1. Does that make sense? Where we got that from? A lot of people didn't seem to know how to get an activation barrier from a reaction energy and one of the activation barriers, but it's just this plot, right? And yeah, if you substitute that into here, you're going to get the same as this. Okay? So the final answer there is 95. Okay, and then finally, part E. So unfortunately, parts D and E did depend a little bit more than I would have liked on part C. But again, we tried to make the rubric as generous as possible. And like I said, the final grade for this problem, median grade, was a 25 out of 30. So that's not a very low average. But the inequality that matters, again, from part C, right? And so if we take the ratio of those two things, or if we just divide in that inequality, what you see is that this expression has to be much greater than 1 in order for the first reaction to be quasi-equilibrated, right? So does the ratio of the concentrations change with temperature? No, right? This is constant with respect to temperature. And so all that matters then is the ratio of the rate constants. And so the question then becomes, does this ratio increase or decrease as you decrease or increase temperature? Increase temperature. What happens to that ratio? Does it go up or down? Up? Anybody else think up? How would you know? So what's the activation energy for this reverse step? That we got over here, right? 25. The activation energy for this step was given 45. So what happens to K as you increase temperature? Does it go up or down? Just a single rate constant. Does it go up or down? Up. Which one's going to go up faster? The one with a smaller activation energy or the one with a larger activation energy? The larger activation energy is more sensitive to temperature. So what you're going to have is one's going to increase, one's going to increase more. This is the 45 kilojoule per mole. This is 25. So that ratio is going to decrease as you increase the temperature, which takes you further away from quasi-equilibrium. Any questions? Okay, so part D was worth 4 points, part E was worth 3 points, C was worth 3 points. So that whole second half was only worth 10 points. And part B was worth 5 points. That whole thing adds up to 30. And that was problem 1, which, like I said, I got the stats. Yeah, the mean, was a little bit lower than I remembered. The mean was 22.5. The median was 22.5. The mode was 30, so the most frequent grade was perfect. And the standard deviation was 4.6. Yeah?
Could you start telling us the point distribution so we're not wasting our time on stuff that's not worth as much?
You mean by part?
Yeah.
The only problem is if I do that, I can't change it afterwards. So if you guys all, screw up one part, I can't minimize the damage. You guys just got to feel it. I mean, no, that is entirely on you guys. I mean, I don't know if I figure out how to do a poll or something, but I understand the merit behind that. But I minimize damage on regions where you guys didn't do well. So right now it's like, damn, I spent 10 minutes on that 3-point problem. Part of the reason why it was in 3 points is because not everybody did very great on it. Otherwise, yeah, I mean, I wouldn't have any problem with it, but I can't change it later because I feel like that's pretty screwed up.
Dr. Rivens,
Yeah.
do you have like a ballpark idea of what the average is, like grade-wise, like a B, B-?
I don't know what you're asking.
I'm saying ballpark.
I mean, just help me out.
You said the average was 67%.
Yeah.
What letter grade would that correspond to approximately?
Oh,
You can't even give me an approximate.
I mean,
A minus.
I like your optimism. I mean, I'm going to talk to some people and see what people generally do, but I understand they curve it. I just want to talk to people to see the extents of curves. I mean, in my mind, a C plus is average, right? But if that's not the case here at this department, then I'm willing to be flexible. That's why I said I'm going to talk to some other faculty before I'm assigning final grades. Yeah. Now you guys are all going to lobby for who I should talk to.
B minus should be
All right. So let's move on to the next problem. So this problem was not lifted out of a real publication, but very much inspired by one. That's where this big drawing came from, is I just copied and pasted it out of a published article. So I liked it because there's some real world flavor in here. This is actually how people set up and run these reactions. In order to, in this case, the point of the paper was to measure the equilibrium constant for this reaction. So it's methanol dehydration. You make DME and water. And you're given a fairly long expression for getting the equal